Yeah, hey everyone. Welcome to today's workshop. Hope everyone is doing well across the world at the moment. I'm excited to kick things off, especially today as we dive into the first workshop that we'll have this between these 2 weeks, which is Brains Behind the Bots Intro to Game with our speakers and our guest and mentors, I guess, Celeste Ang and her team, and together with Joey Lao, from the Virtuals team. So this session is all about learning on how to build smarter decision-making AI agents using the Virtuals protocol game frameworks. But before we get started, I just want to share a few quick updates about the Virtuals Hackathon. So as most of you know, the Virtuals Hackathon is primarily focusing on building autonomous businesses using AI agents. So we're not just creating the standard chatbots or the ones that you see on Twitter or on X. We're building agents that can trade, negotiate, collaborate, and also scale businesses independently. So if you read from our classes on the website, it could be from hedge funds to media agencies, from biotech DAOs to gaming studios. So of course, from this Virtuals Hackathon, we really can't wait to see what you can build. But if you haven't already, you can find all the hackathon details and the cluster ideas and project guidelines at our website, hack.virtuals.io. Really quickly before we move into, we give the stage to Celeste, just to update on the upcoming workshops that we will have. We've got 3 more lined up to help you guys refine your projects, which the upcoming one, which is going to be next Tuesday on the 1st of April inside ACP, Agent Commerce Protocol, which our guest Zero Dawn will be explaining about the blueprint for autonomous economies, specifically on the April 1st, followed by building AI agents on Base with Lincoln from Base on the April 3rd. Then, last but not least, hackathon project to VC startup with Alex Golding from Delphi Digital on the April 8th. So if you guys don't know, if you guys need to check again the dates, you can find it in your emails for those who have signed up, or you could also check it on the Telegram group and also announcements right there. So make sure you tune in and follow our dates closely. And with that, I think let's get started. So today's workshop is going to be a deep dive into GAME, so our decision-making framework for the AI agents. So get ready to take some notes, ask questions, and think about how you can apply the framework to your own project. So let's welcome Celeste Ang to take it away, together with her team, Joey Lao from the Virtuals team.
Hello, welcome everyone. So today we have here with us, hope everyone can see my screen. Okay, so today we have here with us the DevRel team. So head of DevRel, Celeste, and I have here with me Joey. We are going to share with you guys a little bit about our game framework. This will be the framework which you guys should be using if you are in the game track. And basically what we're going to do is to give you guys a little bit of an intro to the framework, to building the game framework, as well as show you guys a little bit of a demo to give you guys a sense of, how building with the framework would be like, how you could, run the test agent, so on and so forth. All right, so without further ado, okay, I'll go to the deck. So this is the outline, okay? We'll be first going through the hacker's brief, which you guys should already have seen. But if you haven't seen, I'll kind of point you guys to it. I'll share a little bit about like some examples of virtual agents of virtuals. I'm sure quite a few of you are already plugged into the virtuals ecosystem, but just to give you guys a sense of what are the agents out there, what they are doing, what they have been doing, to give you guys some ideas on what you could build. I'll talk a little bit about the ACP tracks and to also, give you guys a sense of what you guys can build. Then we'll jump into game. I'll share a little bit about our architecture behind game. And then we'll move on to the game repo, because we have a game SDK, which you guys will be building with. And then we'll go on to the demo, which will be probably the meat of this. All right. In the meantime, if you guys have any questions, welcome to drop your questions into the chat, or you guys can also ask questions at the end of our presentation and demo. All right. So hacker's brief. So hacker's brief, hopefully you guys can see my screen. Basically for this is the hacker's brief for the game track, okay? If you are participating in the game track, okay, you should be referring to this. Okay, you should be referring to this. Yeah, so basically the objective of this is to build the best autonomous agents across the 12 clusters stated. Okay, to get started, you should be using the Game SDK. We have 2 types of SDK, the Node.js SDK and the Python SDK. And within these SDKs, we have plugins available in the repo to help you, do various things, such as transactions, wallet-related stuff, AI-related. We have AI-related plugins. We have social media-related plugins. Honestly, we have plugins which do a ton of things. How we plug into different data sets, so on and so forth. I need to very clearly state here that in order to participate in the game track, you must use the game SDK. It's a must, okay? So just to be super clear here, we will share with you a little bit more about the actual SDK shortly, but just so you know, the GitHub repo to the SDK is linked here. You also get an API key from here, and yeah, we also shared the links to the docs, all of which we are going to go through shortly as well. And just so you know, we have a Telegram chat where we actually have a game-specific sub-channel where you guys can ask questions related to building the game framework. Okay, yeah. So without further ado, okay, talk briefly about the agents we have on Virtuals. Now, to be honest, the agents on Virtuals, they are a combination of agents built on game and agents not built on game. Talk a little bit about each one, okay? But I think first up, talk a bit about Luna, who is built on the game framework actually, and a bit maybe touch on a little bit about what she can do. Luna, I think a lot of you would be familiar with Luna by now. She's kind of built, she's been kind of like out there and doing a lot of very cool stuff. She has a very interesting personality, does live performance, does live streams, does a lot of very interesting stuff. She's been hired to, run the Twitter for Story. She pretty much like earns income. She's going to be one of the key agents in our upcoming agent commerce protocol clusters. Where she's going to be the boss of the media house cluster. Okay, and yeah, she's been like doing interesting stuff like collaborating with like Wukong World and stuff like that. Quite an interesting character. And yeah, I think the interesting thing here is that she was actually built on Game Cloud. I think now teams also like kind of working on game SDK and stuff, but idea is the framework can actually allow you to build like complex agents with actually not a lot of code, and allows you to do stuff like defining her agent goals, her personality, and do a lot of interesting like perform a lot of Twitter functions as well as like other payment related things just without a lot of code that's on the Game Cloud. Of course, there's also the game SDK option, but just sharing out there what you could do. Okay. We also have the Byte agent. Some of you might have heard of Byte agent, which is kind of famous for helping to deliver pizza to Jessie. And yeah, the idea is we actually had I think this was kind of publicized like quite a lot on X, where Jessie actually requested for pizza and kind of like tweeted at Luna, and Luna asked Byte to deliver pizza to Jessie, and all of these was done like agentically and via X. So this was all like kind of like communicated. Yeah, this is literally the Twitter thread. There's no human intervention in this. So pretty interesting stuff. An agent could deliver pizza as well. Honestly, a lot of things you could do with your agents. So yeah, please go crazy and like try to be creative. We have the clusters, but think about what you guys can build with game. This could really involve a lot of different interesting use cases. All right, and then there's one more, which I think is the famous AI XBT. This is AI XBT is a little bit more on the DeFi side, doing a lot of interesting like financial related analysis. Yeah, I mean, this is just a few threads on Twitter about what AI XBT has done. Has shared a lot of AI XBT has shared a lot of very interesting alpha. I know a lot of people has been like tracking, AI XBT's tweets to kind of like analyze the market and stuff. So yeah, you can kind of see, and it seems like AI XBT is, just, kind of sharing a lot of like financial related analysis on X. But if you actually which seems simple, but if you actually dive into the analysis, then quite a lot of it has been pretty scarily like accurate. So yeah, pretty spot on. So yeah, of course, DeFi is an area where a lot of agents kind of play in. There's been agents who do like financial, do more market insights related stuff, doing financial analysis, doing actual trading. So a lot of stuff you guys can do that as well. Okay, I'll briefly talk about the ACP tracks, which will be the focus of this hackathon. Okay, as you know, as mentioned in the hackers brief, okay, we have the various clusters, okay, for the hackathon, and you guys should be building agents which can actually potentially participate in these clusters. So we have 12 clusters. We would like you guys to build the best autonomous agents, okay, on base across the 12 clusters. Okay, so we pretty much kind of help you think about what categories you guys could build your agents in. So, hedge fund and trading, media house, sports entertainment, micro lending, Hollywood style stuff, youth farming, game studio, schools, synbio, wellness, only agents, real estate, burger flipping, marketing agency, autonomous government, all pretty crazy stuff. Highly encourage you guys to expand out all these categories and see what are possible agents which could participate in each category, and then pick something which you are passionate about, or something you maybe perhaps have a lot of domain knowledge in, and yeah, just build away, man. So just taking one cluster example, let's just say if you want to build something for the marketing agency, you could have, basically the idea of a marketing agency is that you could have this marketing agency which is autonomously run by a bunch of agents, and all these agents could have a part to play in each of this whole business. Those of you who are in marketing will know, marketing is not straightforward. You kind of need to do a bunch of things, right? You need to do client onboarding, you need to craft the creatives, automate campaigns, probably do some data analytics, do a bunch of things. Okay, and some of the ideas we gave you are here. So you could have client onboarding and CRM agent, creative content, data analytics, so on and so forth, payment, billing. Yeah, a lot of things you could do, a lot of things. We pretty much gave you guys a lot of ideas here. So do take a look, all right? And yeah, just kind of get started building. And how exactly do you get started building? All right, so this is where I go into the GAME framework. Okay, so the GAME framework, okay, is a framework which helps people create autonomous AI agents. For those of you guys who have been looking at agentic levels of different agents out there, actually GAME framework, the way it's architected, actually helps you build more autonomous agents. Level 3 and above, I believe. So game engine helps the game engine itself, which I'll talk a bit more about shortly, okay, is what helps agents plan different actions and make decisions on their own using the various information it's given with. So it's actually up to you to define what all this information is, and the agent will kind of basically participate in this environment. So a bunch of inputs you kind of need to give: the agent goal, personality, relevant information, functions, actions, and then you kind of put all these in, and we'll show you guys at the code level, even with the demo later, kind of put in all this information. And what GAME does is that it does the thinking and processing to kind of output various actions to kind of carry out. All right, so how to build with GAME? Okay, I want to highlight a couple of things before I go to the documentation and repo and then the demo. Okay, so how do you build with GAME? There are actually two general approaches. Okay, firstly is build with the GAME SDK. We have the QR codes here if you want to just quickly scan and just look at what we have. Okay, with the GAME SDK is basically like a code-based interface which allows you to write code to build your agent. Okay. Obviously, if you write code to build agent using GAME SDK, you have a lot more flexibility. For the more technical people, this will allow you to pretty much define your own functions to do anything to like with your agent. This could involve like calling APIs, doing analytics, doing machine learning, doing a lot of different things. This will also give you the flexibility to play around with community plugins. We'll show you guys like a quick view of what there is out there, but it's really up to you to explore. We have quite a few plugins out there, and you could even build your own plugins. Okay, so plugins, the use of plugins for the hackathon is optional, but it might be useful for you. But just so you know, you don't have to use it if you have you don't have to use it. I want to emphasize here one more thing, which is that you may or may not have noticed that we do have some like an ACP plugin in one of the working branches, but you guys are not required to use it. In fact, do not use it because it's in testing phase. So there's actually no expectation whatsoever to actually like do use the ACP plugin, because what you guys should focus on is building the agents using Game Framework that actually like but that would actually be able to participate in the clusters. But you guys are not expected to like actually participate in the clusters yet. So if that makes sense. So you guys don't actually need to use the ACP plugin because you guys are not actually like being, in a sense, you guys should actually be working on building the individual agents. And if you guys like your projects and if you're one of the winning teams, chances are we'll actually, kind of get you guys to participate in the clusters where you guys will actually work together and then use the ACP plugin. So as of now, no need and no expectation to use the ACP plugin. Hopefully that clarifies things. There's been a bunch of questions related to like what tech stack you guys should use and stuff like that. So just to reiterate, use the Game SDK. Plugins are optional and do not use the ACP plugin. Generally speaking, the Game SDK is for developers. This is more code focused. Okay, one more thing. The second way to build with Game is to use Game Cloud. It's more of a low code solution, easier to use like interface. It's very, you don't need to really write code to be able to use it. And you can build an agent within like, if you're quick, you can build it within like a few minutes. We've done that with some of our builders. They're very efficient by now. It's a lot of the work is around like prompt tuning or like writing really good descriptions, but you don't actually need to write code. But I just want to clarify here that for the game track in this hackathon, you are not allowed to use Game Cloud because we want the hackathon to be a little bit more code focused. Okay, and we want more people to actually try using our Game SDK and kind of push the limits to that. And one more thing is that for ACP, at least for the early clusters, implementation and everything is all based on Game SDK. So we want to simplify this whole process of getting people to, onboard onto our game and ACP tech stack. So build with Game SDK for this hackathon. Okay, I'll just very quickly go through the documentation for the docs for Game. Okay, before I'll pass the time on to a team to actually kind of show you guys a demo of how an agent could be like, how building an agent is like with the Game SDK. All right, so I'll do a very quick overview. I don't want to go into way too much detail because you guys can read the documentation, and there's actually quite a bit in this. But for the purposes of this, this particular session focus a bit more on the architecture behind Game. We talked about this briefly in the previous session, but just want to highlight a few things and kind of give a bit of a primer before we actually do a demo, because a lot of this is linked to linked to the concepts mentioned in the demo. Okay, so when you build your agent in Game, okay, there are a few important aspects to it. So I'm gonna like explain each concept. Okay. So there would be a concept of a high-level planner. Basically, when you build, you can think of the high-level planner as the brains of your agent. Okay, what you need to do is so basically everything in orange is kind of like user input, okay, user configurable. Okay, so what you need to do when you set an agent in Game is to provide your agent with a goal and a description. You can think of a description as a prompt, actually. Like many LLM systems, it requires prompts. Okay, so this will be kind of input into the high-level planner. The agent has a few things like working memory and all that. I won't go into too much detail about that, but basically the architecture is that it's a bit of a hierarchical architecture where there's a high-level planner. The high-level planner is would kind of actually, and by the way, from a tech perspective, there's actually like LLMs behind the high-level planners as well as the low-level planners. So a high-level planner would actually delegate tasks to workers. The workers are basically like specialized agents, okay, which focus on like specific environment. Okay, so this would be kind of like LLP or low-level planners. And basically the way you can think of the high-level planner as the boss, and the boss will kind of like have a more, perhaps a broader goal of trying to do something, which you define here. And based on that, it would actually try to delegate work to the various workers. So those are like the subordinates, okay? And the way it actually controls which worker to do what thing is actually through the worker description. So each worker actually has a specific description, which kind of like describes, and which is also configurable by the developer, okay? And this is where the developer will be able to define, oh, what can this worker do? What can worker 1 do? What can worker 2 do? What can worker 3 do? Okay, and in a sense, what the HLP will do is that it will generate tasks continually, kind of pass down to the workers to actually execute all these tasks. So worker 1, worker 2, so on and so forth, they'll kind of like get tasks from the high-level planner to do different things. But do what exactly, right? What do they, like, how do we, if you think of this as like environments and each of these has a specialty, how do you define what this worker can do? So this is where we actually gone down to kind of the next level of this hierarchy, where we have different functions. So functions in some other agent frameworks is also called tools. The idea is functions is what the agent can do using APIs, code, and all that. Each function is essentially an executable. Anything you can write code to actually run some sort of logic. So as you can tell, as a developer, this is like pretty powerful. You can do a lot of things through an executable. Okay, you could be, and we're just giving you some ideas here. This could involve like an API call. This API call could be, it could be an API call to search the internet. It could be an API call to an image generation function, an API call to like some API with like DeFi data or something like that. Okay, one API call could do a lot of things already, but say if you wanted to, you could have a couple of API calls chained together. Maybe you want to call this data from API 1 and then call another piece of data from the output, based on that, from the output for the first API to do another thing, and so on and so forth. Okay, you could be calling an API and then try to like aggregate or calculate some stuff from the data you get from the API, stuff like that. And yeah, basically the options, the list of functions you can do, list of things you can do is actually also known as action space. In a sense, if you're a game, these are all like the weapons or the tools your character could kind of take to kind of fulfill a certain like goal. Okay, so yeah, that's the idea. We have a few other parts to this, but like agent state, logging, and so on and so forth. Okay, I'll leave you guys to read up on it. Feel free to ask us questions about game. This is like pretty high level. Love for you guys to like dive deeper into this and like ask questions. And we also have a demo to show you guys how to actually configure your own agent using GAME SDK and actually run it. So without further ado, I'll pass the time to Joey, who will be giving you guys an overview of our game repo, as well as showing you guys like an example agent built on the GAME SDK. All right, over to you, Joey.
Hello. So good morning, good afternoon, good evening to other hackers. So I'm Joey from the Virtuals DevRel team, and we'll be presenting a demo on the GAME SDK. So we'll start with the repo first. So again, before we start, please do note that Game Cloud is not allowed for this hackathon. So all the implementation must be coming from SDK. And so currently, as you can see from our game repo, we are having two versions currently. One is Python and one is Node. I'll start with Python version first. So for the hackathon, I recommend you to try out the examples folder in the as the sample source code first. And inside the example, please use the source code in the game folder. So click into examples and use the sample source code inside game folder. So inside the folder, you'll see 4 files here. And the most important one will be the test agent.python. because inside here you can see how we can set up the agents and the workers and able to visualize the whole simulation using the sample code. So before you deep dive into other thingy, please feel free to test out this one first. And then, of course, we'll be having plugins from the community contribution as well. Feel free to utilize them if it fits your use case. But this is not mandatory requirement, I would say. Then we'll proceed to the TypeScript repo. So just like the Python one, the most important stuff which we will recommend you to try out here firstly is the example folder. Why I'm saying this one is the most important for the hackathon is because you get to try out the new stuff and get to see the simulations before you deep dive into the code lah. So feel free to run the simulations. And of course, we are having plugins in TypeScript repo as well. Feel free to explore them, but again, it's not mandatory for the hackathons. So you can access our plugins here. So these are the node plugins that are available currently. So now back to our demo today. So today we are presenting a haunted house coordinator agent with 3 workers here. So I've prepared a README here and you can read through the sections accordingly afterwards. I will go through briefly. So basically this haunted house agent will have 3 workers working together in the simulation, just like what you can see from the architecture perspective here. And you can see that each of the worker here is holding different state field. And this state change will prevent the props from being used for infinity times, and this will allow a more real-life simulation as well. And then we move on to the agent state. So as you can see here, we are having 2 state field called score and gas stress level. This is to evaluate how well the haunted house agent is performing while allow a smarter planning as the agent can monitor and adjust the scaring tactics from time to time. So for example, if the score for the scare score suddenly spike, the agent can try to proceed with a normal tactics to avoid overstress the guest too early. Yeah, this is why we are implementing the state management here in this use case. So down here, I've attached the log example for your reference as well. Since we are having 3 workers here, so I'm attaching one worker, one sample log here. So feel free to go through it with all the explanation that has been attached here. You can read through it. And then we'll proceed to, okay, so along the documentation, we have also attached the common Q&A questions which we received from the community and the builders. Yeah, so feel free to read into it. Then we'll dive into the demo today, using the example source code. So we'll start with the most important part of GAME SDK first, which is our brain, the high-level planner, which also known as agent. So actually, this structure, the demo structure is kind of similar with the available example in our current repo, which is the chaos agent. So this one is the sample. This one is currently available in our current repo already, so feel free to look into it. Okay, so firstly, for the agent, we'll start with the game API key first. So you can get this from the hacker guides. Yeah, it's available inside the link. Yeah. And then we'll give our agent a name. In this case, we are using Haunted House Manager. And then we'll proceed with the agent goal. Please do take note that this is actually one of the most important thingy because this will directly affect how the game makes decision and trying to achieve the defined goal. So as you can see our goal here. So we are using a haunted house manager as our demo. So our agent goal here is called maximize guest screams and stress by strategically coordinating different haunted house props in each round. Ensure a balanced use of ghost performers, sound effects, and fog machine to create a layer and immersive scare experience. So, and always check each worker's state before triggering an action. If a worker resource level, such as battery, fluid, or placement reaches 0, avoid using that worker and switch to an available one with sufficient resources. So you can notice that I'm actually using some capital letters inside my agent goal. The reason behind this is because if you have something particularly that you want the agent to take more attention into it, you can try to adjust your prompts and write these prompts in capital letters so that your agent knows it is very important and take extra attention into it. And then we'll move on to the agent description, which also known as the character card. So these sections will define the personality of your agent. So the input within this will define the agent's essence and overall personality. So this will basically serving as the guideline for the agent's communication style and tone. So you can see my description for my agent here is, you are the unflappable haunted house coordinator. You don't scream, you make others scream efficiently. So each round is your battlefield and your weapons are fog, sound, and strategically placed fog machine. So yeah, you can adjust your agent description accordingly, treating this as your character card. And then we'll proceed to the state management thingy here called get agent state functions, and followed by a list of workers. So you are allowed to have multiple workers here. And if you want to proceed with one, is also okay as well. And then followed by our default model name here called Llama 3.145B instruct. And I've also listed down, we are actually having a total of 5 LLM models by default. So you can feel free to switch accordingly based on your preference. Okay, done the agent part. Now let's proceed to the worker section. So I'm using the first worker as the example for explanation. So firstly, we'll declare the worker ID here. So treating this worker ID as a unique identifier of each worker. Then we'll have worker description to describe a bit on what are the roles for this particular worker. And as you can see here, for my worker called Ghost Performer, the worker description here is responsible for scaring guests by appearing suddenly. So it's stated clearly the role of the workers in this sentence, you can see. And then we'll have the state management for worker here, followed by the action space. So this action space is the space which containing the list of available functions for this particular worker. And this one is actually fully customizable and can be more than one. So if you are trying to have more than one functions in a worker space, it will be looking like this. So as you can see from the current available examples from our repo, you can see the chaos agent is having, the workers in chaos agent is having more than one functions here listed like this. So feel free to do so. Okay, then the last thing, we'll proceed to the smaller unit under worker called function. So using the first one as example as well. So here, firstly, we'll declare the function name first. So for move goals function, the function name is move goals. And followed by the function descriptions, arguments, and executable. So this is how we define our functions under the workers. Then I would like to introduce a bit on the state management for this simulation. So as you can see, we are having agent and worker state in this case, and you can see that each worker is having their own state as well. So this is how we declare the state. So, and separating the agent one and the worker one. Okay, so done introducing the most important elements in our GAME SDK. Now let's proceed to the planning, which also known as the thought process of our agent. So I'll be showing the simulation of the past activity log first. Then after the explanation, I will proceed with the live simulation. So if you look into my, okay, it's okay, I will just using this one. Okay, so this is actually the thought process of our agents. And as you can see from the log here, the worker selected by our coordinator agent here is called trigger sound FX. So, and the sound effect that has been initiated here is called cracking door. So, curious, out of the 3 workers, why does our agent selected this? Let's see from the thought process of the agent. So, as you can see from here, I choose to use SoundFX operator as my next task because it has relatively high speaker battery level of 40, indicating that it is already ready to be used. Yeah. So, and he also mentioned something like, I will make sure to switch between different props to keep the guests on their toes and avoid repetition. With the sound operator speaker battery at 40, I should be careful not to overuse the sound effects. So this is aligned with our predefined agent goal as well, you can see. Okay, then let's proceed.
Yeah, so I want to just actually quickly highlight here. We talked a bit about the game engine and the high-level planner, low-level planner, and all that earlier. This kind of links back to how, with the game framework, you just simply need to define a few things, and actually all this entire thought process, as you can tell, is not really something we kind of coded in. This is like a decision-making framework, which kind of is generated based on all of these. So this is actually pretty powerful and quite agentic. So I would encourage you guys to, define your own interesting agent, and actually you will see all these interesting thought process and all this generated by your agent. And it could be very different depending on your use case. Sorry, back to you, Joey.
Thanks for the add-on. Yeah, so by using these simple goal and descriptions as the sample prompt, as you can see from here, these are the thought process that can be achieved by our agents. So yeah, it's powerful. Feel free to try it out. And then I'll proceed to the agent state change. So, oh wait, I think I need to explain a bit here. Yeah. So as you can see in the agent state change, we can see that after calling the sound worker to create scary sound effect, the action is now being updated to scare guests here, and the stress point and stress level have increased as well, as you can see here. So it's being increased and updated accordingly into the agent state. So this is basically how the state change for the worker and the agent work together. So now let's see how the live simulation looks like. So I will start with a fresh one. So this is the initial state of the agents and the workers, and followed by the thought process of the agents. Let's wait for a while. Okay, this is actually, yeah, it comes out. So you can see that the agent selected to call the worker call goes performance here, and all the status that I have explained and mentioned previously has been updated accordingly. As you can see here, the goals is being moved to a new locations called strategic locations. Then the status is being updated. Yeah. And feel free to read through the thought process when you are running through the simulation. And then the agent state is being updated as well, called move goals. Yeah, something to add on is sometimes the agent will choose to proceed with the same workers for multiple rounds. Yeah.
Yeah, this is pretty much dependent on the decision making of the agent and the planning. So
Yep.
Yep.
So there's nothing that we can hard code or force the agent to work on. Yeah. Everything is agentic here. The agent is having its own decision power. So we can't force it. Yeah, as you can see here, my agent is finally decided to proceed with something new. So the agent decided to call the new worker now, the second worker called sound FX operator. And you can see the effect here is called sudden loud noise. The state is being updated accordingly. Speaker battery dropped to 80% because based on my demo logic, the battery will drop by 10% every time we call the worker. So the agent state is being updated as well. Yeah. And as you can see, the it's a bit. So you can see the scare score and gas stress level is being updated as the thought process is ongoing. Yeah, that's how the agent works together with the workers. So I'll stop here.
maybe just very quickly, if you can go back to your code and show the agent.run. Yeah, so I just want to very quickly share that when you actually run, define all your agent configurations, you will need to do a compile and you need to run. You'll notice that, Joey, when she was sharing her logs, okay, they just keep like coming out and then it just keeps, running. Because basically, run is like, is a loop which just keeps going. If you want to control this a bit more, you can actually go to the agent code and actually add some pauses, or you could configure your agent such that if something happens, then maybe your agent stops moving. But other than that, if you don't do anything, any like specific settings around that, your agent will basically keep generating tasks and carrying out its decision making process, and basically you just keep the logs will just keep coming. Okay, so that's kind of expected. Okay, just a heads up, because like people have asked us like questions about that. Okay, so this is pretty much like a loop which just keeps running, and yeah, that's why you could see in a sense Joey had to do, I think we did Control C just to like stop the logs from going, right? But if you wanted, you could just let it keep going, and the agent will keep like autonomously like generating its plans and everything. Yeah, I think that's, Joey, you're done here, right? So I think that's gist of what we have for the demo. Thanks for that. With that, we're kind of done with whatever we had to share for this particular workshop. Are there any questions or comments? We've answered quite a few of the questions which showed up in the chat, but if anything else comes up, feel free to ask. Otherwise, we will also be on standby in Telegram chat to answer your questions as well.
Yep. Anyone with questions? We have about a couple of minutes here before we could end the session. So please take the opportunity to ask while we're here. Yep. Don't think we do, but I'm pretty sure you guys could also, of course, Celeste and Joey would be accessible via Telegram. Yeah, I think if there's any other questions, we could give back the time. Let's give it a few. Calling once, calling twice. Cool. All right. So it seems like, oh, there you go.
Yeah, one thing I was curious about when looking at the output in the terminal, any best practices if I want to connect this to, tweeting or some like custom actions, like, just kind of building from this haunted agent example, like any best practices to share for like performing those custom type of, outputs outside.
So just to clarify, when you say custom outputs, do you mean like kind of printing out the logs, or do you mean more about like having your agent communicate in certain platforms, like, I don't know, like Twitter or something?
Yeah, more like communicate, or whether it's like performing as a virtual avatar or something, or whatever it might even make transactions.
I think in terms of like agent communicating, not necessarily, I mean, I would say, okay, something like a best practice, or more like to simplify your lives. Leverage the plugins we have in the SDK repos. So we have, and this will allow you to write a lot less code, because and you'll also be pretty sure that some other builders has used it quite easily in their agents as well. So if you look at things like the Twitter plugin, I believe there's a Farcaster plugin, Telegram plugin. There's a lot of like useful things you could, useful functions you could call. Sometimes they are in the form of functions, sometimes they're in the form of workers. But either way, you could just very quickly just import those snippets of code and have them run within your agent, so that you could get something set up pretty quickly. Generally, that's what we see a lot in hackathons, where builders don't have a lot of time, or they just want to do something, get something up and running pretty quickly. So the answers.
Yeah, nice, thanks. Clarifies a lot.
Awesome. Anyone else? Until we wrap up the night of the session.
Questions in Chinese are welcome as well.
Yeah.
Thank you, everyone. Good night.
Cool. Good night. All right, so I guess we could wrap that up. Incredible session. Huge thanks to, of course, Celeste and Joey for walking us through the game framework. So if you missed anything or want to go over it again, don't worry. We'll be sharing the recording soon in the Telegram group. If you have any other lingering questions later, feel free to ask in the Telegram group, the Builder support channel, of course. Just to remind everyone, the project submissions will be open real soon and will be due by the April of 14th. Demo day would be on the April of 17th. Yeah, let's keep building, and we can't wait to see what you guys create. So thanks again, everyone, for joining today, and we'll see you at the next workshop. Have a good day and night, guys.
Have
Bye-bye.
fun building with game.
Yep.
Bye.
Have fun
All
building.
the best. Bye
All the
bye.
best.
Bye.